The sun, our life-giving star, is waking up. Over the past year, scientists at NASA and NOAA have been watching it closely, and the numbers are impossible to ignore. Sunspots are multiplying, solar flares are becoming more frequent, and powerful eruptions of charged particles, called coronal mass ejections, are racing toward space at incredible speeds. This is not just an abstract phenomenon happening 93 million miles away. When the sun ramps up its activity, Earth feels the effects. From dazzling auroras that light up the night sky far from the polar regions, to occasional disruptions in GPS signals and satellite communications, the sun reminds us that we are deeply connected to it. Right now, researchers say we are approaching the solar maximum, the peak of the sun's natural 11-year cycle. And this one might be stronger than many predicted. What does that mean for our planet, our technology, and our daily lives? Should we be concerned or excited? In today's video, we'll explore what's really happening on the sun, why its activity is rising, how it could impact Earth, and why this is one of the most fascinating times to be alive. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. To understand why the sun seems so busy right now, we need to look at its natural rhythm. Our star follows an approximately 11-year cycle, swinging from a quiet phase called solar minimum to a stormy, energetic peak known as solar maximum. During solar minimum, the sun's surface appears calm, with only a handful of sunspots. As it climbs towards solar maximum, those sunspots multiply dramatically. Each one marks an area of twisted magnetic fields, which can unleash solar flares, bursts of radiation, and coronal mass ejections, massive eruptions of charged particles that blast into space. Scientists track these changes with satellites such as NASA's Solar Dynamics Observatory and the ESA NASA Solar and Heliospheric Observatory. They count sunspots, measure solar wind, and watch for geomagnetic storms that can affect Earth. And right now, the sun is not just approaching its maximum, it's already there. NASA and NOAA recently confirmed that we are in the solar maximum period of solar cycle 25. What's remarkable is that this cycle is stronger and arrived sooner than early forecasts suggested. The exact peak, the moment of highest activity, is expected to occur sometime between late 2024 and mid-2025. But the elevated activity we are seeing now is already giving scientists a wealth of data and the public some spectacular sky shows. This is not cause for alarm. It's a natural, repeating process that has shaped Earth's space environment for billions of years. By studying these cycles, scientists can better protect satellites, astronauts, and power grids from the sun's most powerful outbursts. But to truly appreciate why scientists are so focused on the sun's behavior today, it helps to look back at history. One of the most dramatic examples came in September 1859, during what is now called the Carrington event, the most powerful solar storm ever recorded. On a quiet morning, astronomer Richard Carrington was sketching a sunspot when he saw a sudden flash of light, the first observation of a solar flare. Just hours later, Earth was struck by an enormous geomagnetic storm. Telegraph systems, the high-tech communication network of the time, went haywire. Operators were shocked by sparks from their equipment, and in some cases, telegraphs kept working even after being disconnected from their power supplies, powered only by the storm's induced currents. Auroras were so bright they were seen as far south as Cuba and Hawaii, lighting up the night sky like dawn. More recently, in October 2003, A series of extreme solar storms, nicknamed the Halloween storms, gave scientists and engineers a real challenge. These storms caused temporary blackouts of radio communications, forced airlines to reroute polar flights, and even damaged satellites. Astronauts on the International Space Station had to shelter in shielded areas to limit radiation exposure. But these events also pushed space weather forecasting forward, proving how critical early warnings can be. So what exactly is happening when the sun unleashes one of these storms? At the heart of the process are the sun's magnetic fields. They twist and stretch over time, storing energy like a wound-up spring. When those magnetic field lines suddenly snap and reconnect, they release a tremendous burst of energy, producing solar flares and coronal mass ejections. This is why solar maximum is so active. The sun's magnetic field is at its most tangled and dynamic, creating perfect conditions for these explosive events. Far from being a reason for fear, this cycle gives scientists a front-row seat to study the sun in its most dramatic phase. Missions like NASA's Parker Solar Probe and ESA NASA's Solar Orbiter are now flying closer to the sun than ever before, sending back data that will help us predict space weather more accurately in the future. Artificial intelligence is even being trained to recognize patterns in solar activity so that we can issue earlier warnings and better protect satellites, power grids, and astronauts. All of this means that while solar maximum can be challenging, it's also an incredible time for discovery. For many of us, it's the best chance we'll ever have to see auroras dancing outside the polar regions, or to watch as scientists make real-time discoveries about the star that sustains life on Earth. So, what does this increased activity look like in practice? Let's explore the hard evidence, from record numbers of sunspots to the most intense solar storms we've seen in years. First, the sun's surface has been teeming with sunspots. In mid-2024, NASA reported monthly sunspot counts, more than double the early predictions for solar cycle 25. Some active regions have grown so large they could swallow Earth several times over. Each of these regions carries twisted magnetic fields capable of unleashing solar flares, and that's exactly what we've been seeing. In the past year, the sun has fired off dozens of X-class solar flares, the most powerful category. In May 2024, a series of intense eruptions produced the strongest geomagnetic storm in more than 2 decades, classified as G5, the highest level on NOAA's scale. This storm caused spectacular auroras visible across much of North America and Europe, reaching as far south as Arizona, Spain, and even parts of Mexico. For millions of people, it was the first time they had ever seen the northern lights from their own backyard. Coronal mass ejections, CMEs, have also been more frequent and more powerful. These vast clouds of plasma race through space at millions of miles per hour. When they collide with Earth's magnetic field, they can create geomagnetic storms that disrupt radio communications, affect satellites, and in extreme cases threaten power grids. Fortunately, most storms in this cycle so far have been moderate, but they remind us of how closely tied our technology is to the sun. Even astronauts on the International Space Station have taken precautions, sheltering in more shielded parts of the station during periods of high radiation. Satellite operators have reported slight orbital decay caused by the heating of Earth's upper atmosphere from solar activity, requiring small adjustments to keep satellites in position. Taken together, these events confirm what scientists predicted. Solar cycle 25 is both stronger and more active than expected. And while this increased activity can sometimes be disruptive, it also offers a rare opportunity to study our star at its most energetic and to witness sky spectacles that inspire awe and curiosity. With this evidence in hand, the question becomes, what does all of this mean for us here on Earth? How can these solar storms affect our technology, our communications, even our daily lives? Let's explore the impacts and the steps scientists are taking to keep us safe. All of this solar activity isn't just a distant spectacle. It has real consequences here on Earth. When a coronal mass ejection reaches our planet, it slams into Earth's magnetic field. This triggers a geomagnetic storm, which can range from barely noticeable to extremely disruptive. The strength of these storms is measured using the KP index, from 0, very quiet, to 9, severe storm. During the G5 storm of May 2024, KP values briefly reached the maximum, a rare event that happens perhaps once or twice per solar cycle. The most beautiful effect of these storms is the aurora. Charged particles collide with atoms in Earth's upper atmosphere, causing curtains of green, purple, and red light to dance across the night sky. During strong storms, auroras can be seen far beyond their usual polar range, thrilling observers as far south as Texas and Italy. For many, these displays were not just a scientific curiosity, but a deeply emotional experience. But geomagnetic storms are not just light shows. They can interfere with high-frequency radio signals, affect GPS accuracy, and cause brief outages in satellite communications. During severe storms, airlines sometimes reroute polar flights to avoid regions of higher radiation. In extreme cases, though rare, induced electric currents in power lines can overload transformers. The 1989 Quebec blackout is a famous example, when a powerful solar storm shut down electricity for millions of people in Canada. Today, space weather forecasters work to prevent such disruptions. NASA, NOAA, and ESA constantly monitor the sun, giving power companies and satellite operators advance warnings so they can prepare. In many ways, this is similar to how we forecast hurricanes, but here we're tracking storms in space. Even our modern technology feels the sun's reach. The atmosphere expands slightly during high solar activity, increasing drag on low Earth orbit satellites. In 2022, SpaceX lost several newly launched Starlink satellites after a solar storm heated Earth's upper atmosphere more than expected. This forced the company and others to adjust their operations. For astronauts aboard the International Space Station, solar storms mean more radiation exposure. When a large flare or CME is detected, they move to shielded sections of the station until the danger passes. A reminder that space exploration always depends on understanding our star. The good news is that despite the risks, we are better prepared than ever. Improved forecasting models and constant monitoring mean that even during this active solar cycle, we can protect most critical systems. And for ordinary people, the biggest impact may be the chance to see auroras, sometimes from their own backyard. So while solar maximum brings its challenges, it also brings wonder. And as scientists work to understand and predict these storms, we all get a front row seat to one of nature's most spectacular shows. When you think about it, there's something deeply humbling and inspiring about living through a solar maximum. For a brief window of time, we get to witness our star at its most powerful, painting the sky with light shows and reminding us that we are part of something far greater than ourselves. Yes, the sun can disrupt technology, but it also powers life, shapes our climate, and has guided explorers and dreamers for thousands of years. Today, thanks to science, We can watch its storms in real time, predict their effects, and even marvel at the beauty they create without fear. So, the next time you hear about a solar storm warning, don't just think of it as a threat. Step outside on a dark night, look up, and you might just catch a glimpse of the aurora. For many people, seeing those shimmering green and red curtains is a once-in-a-lifetime experience, and Solar Cycle 25 may be your chance. Have you ever seen the Northern Lights, or would you like to? Share your thoughts in the comments below. And if you enjoyed this journey through the sun's most powerful cycle, make sure to like this video, subscribe to the channel, and ring the bell so you never miss an update.